Today we look at the trapezoidal rule, which gives us a method for estimating the area under the curve. Now it doesn't find it exactly, but creates a good estimate, and there's lots of good reasons that we can use this. Now let's start by revising the method of finding the area of a trapezium. And let's go one step back and say, what is a trapezium? Well, a trapezium has one pair of parallel lines. That's it. It's its only defining feature. So if we label it here as the parallel lines A and B, we might have a short one and a tall one, that's fine. Then the other sides have nothing special going for them. And so finding the area of this, to understand what's going on, if we actually make another trapezium that's exactly the same as this one, and we turn it upside down and around the other way, we could sit it like this. And then we would have the short side A sitting down here, and the long side B sitting up there. Now you'll notice that the ends are now making it look like a giant parallelogram. And we know how to find the area of a parallelogram. It's base times height. So if we then say, well, all right, what is the base? The base of this giant parallelogram is A plus B. It's the short side plus the tall side. So we can replace that there. And we're multiplying by the height. That's fine. Let's put the height at the front. Nice and simple. We'll call it H. This will give us the area of this giant parallelogram that we've made. But it's too big, isn't it? It's twice the size of what we wanted. We actually just wanted the area of one trapezium, not two. So we need to halve it, and a simple way to do that is to halve the height. So this is the formula for the area of a trapezium, and this is something that you should have known for a few years now, but it's important that you have this right so that you can apply the trapezoidal rule correctly and think through what you're doing. Now, we're going to be looking at trapeziums that are standing on their end. So if we have a trapezium sitting like that, the defining feature of a parallelogram, remember, is the parallel sides. And in this case, it's standing vertically. So that means that our height is going to be the perpendicular height across. And our A and our B are going to be on the left and the right. They're going to look like the sides. So this is what we need to work with. Now, a really important point to note is that the trapezoidal rule will either over or underestimate the area under a curve, depending on the concavity of the curve. So let's think about this. Here we've got one that's concave up and one that's concave down, between two bounds, A and B. If we actually make this into a trapezium, from this point to this point, we would need to draw a straight line. And so now we've got a trapezium that, if we find the area of this purple section, it will be slightly bigger than the area under the curve. So it won't quite be right. It will be an overestimate. Whereas on this one, if we make a trapezium by joining the straight line between these 2 points, the area of this trapezium will be slightly less than the area under the curve. So this will be an underestimate, this will be an overestimate. And that will depend on concavity. So often you'll need to look at the second derivative of a curve to see what the concavity is if you're asked a question about whether it's an under or an overestimate. Now, if we make just one trapezium, you can see that there might be quite a bit of inaccuracy there. This is how much we'll be wrong by. And in the case of making one giant trapezium, it's not going to be a great estimate. But the more we divide our interval up, down here I've got the exact same curve below and the exact same curve. If we divide up even just from one trapezium up into 2 or 3 or 4, our estimate gets dramatically better. And you can see that that will happen because as I join up the top points here, the straight line is actually going to sit much closer to the curve. And so we'll still have small areas of error in between, which is hard to see on this picture because I haven't drawn it big enough. You'll have little errors in here, but you'll see that if you add up those tiny errors, it'll be much smaller than the big error that you make when you use one giant trapezium. Now you're probably thinking, how many trapeziums should I divide my interval into? Well, often in the HSC they'll tell you, by dividing this interval into 4 sections, give me an estimate for the area under the curve. So you'll often be shown, or there might be something about the function or about the picture that lends itself to a certain number of divisions. So usually it'd be just something logical.